Hey there, we are talking about interpreting graphs, and the graphs on the front are graphs that are already made for us, and we're going to look and see what we can determine by sort of picking them apart. There are three descriptions, and then there are three graphs. So the descriptions say, number one, the speed at which a car is driving on a road trip. The second one is, come on, the length of a student's hair in 8th grade. And the third one, the temperature during one day, a 24-hour period. So we want to figure out which goes with which. So the speed at which a person drives a car. Does a person speed up and then slow way down? Speed up and then slow way down? Speed up? Probably not on purpose anyway. Does a person speed up and then gradually slow down and then speed up and then gradually slow down? Probably not. If we look at this one, you'll notice that this is the only one, C, that starts from 0. Cars do not start at random high speeds. They start at 0. And then you press on the gas and it would increase until you get to a certain speed. This might be cruise control. It also might just be a person who's very consistently driving the speed limit. And then maybe the speed limit goes down. And then they consistently drive the speed limit. And then it goes up. And then they go to a stop for some reason. Maybe there's an accident in front of them. Who knows? But C is going to be the one that is the car trip. Number 2, the length of a student's hair in 8th grade. So when we talk about hair, typically what happens with our hair? So we've already eliminated this one. So we've only got these two left. So what do we do with our hair? We let our hair grow and then we get a haircut. And then we let our hair grow and then we get a haircut. And it's not always the same amount of time. Sometimes maybe we let it grow for 4 weeks and get a haircut, and then 3 weeks and get a haircut, and then 4 weeks. But that haircut is that day where it changes drastically, but we don't necessarily shave our head. So that one is going to be the length of a person's hair. And then 3, the temperature during one day in a 24-hour period. Typically what happens is that you would start at some temperature, whatever it is, maybe at midnight. And then the temperature is going to get warmer over the course of the day. And then it's going to get dark and get cold again. And then the next day it'll go back up. So even though this might not be current temperatures, depending on the time of year, but I guess typically it would be positive degrees anyway. Discuss your answers with a classmate, explain your thinking, and debate as needed. So choose your final answer. So those are our final answers. A is the graph for hair. B is the graph for temperature. Now this is outside daily temperature, because sometimes we do talk about like the temperature in an oven, and that does not operate the same necessarily as outdoor temperature. And C was the car. Do you think of any other situations that can be modeled with any of the graphs above? So yes, there are definitely things that happen like that. Instead of cutting hair, you might talk about cutting grass, where we let the grass grow and then we cut it, and then we let the grass grow and then we cut it. All right. Get this one to focus. How to analyze graphs without numbers. So what can we learn if there are no numbers? Anything going up to the right is increasing. The steeper it is, the faster it's increasing. Something that is horizontal. This is not 0. This just means that there's no change, that something is staying at a constant speed or a constant length. Then anything going down to the right is decreasing. The other thing that we can tell is if something is at 0. So whatever this graph is representing is something that is not starting at 0, but is something that is ending at 0. So we can tell things about increasing, constant or no change, decreasing, as well as the relation to 0. On the back, it says, the school is 100 meters from Jason's house. The following describes his most recent trip. He walked 50 meters towards school in 2 minutes. He realized that he left a book at home. He turned around and walked home at the same speed. So his walking toward the school and his walking back from the school, those will be at the same angle, one positive and one negative. Spent 1 minute looking for the book, meaning his distance isn't changing. So that would be horizontal, no change. And then he walked to school at twice his original speed. That one's going to get steeper. So you'd see something like this, where you've got the walking toward the school and walking back from the school at the same angle, but one increasing and one decreasing. So one going up to the right and one going down to the right. And then you've got the 1 minute that he was looking, so his distance wasn't changing. And then you've got the 100 meters. Let's see if I can get to focus on my finger and come back down. The 100 meters in 2 minutes because he was walking at twice the speed. So that section got steeper. Then at the bottom, you'll notice that there is a graph about bacteria growth. And bacteria growth is exponential, meaning that it comes up to be nonlinear. Depending on the hour, let's see if I can get it to focus on the pen. That seems to be working. It says a scientist is conducting an experiment to study bacteria growth. The scientist grows bacteria that double their numbers every hour. If there are 100 bacteria in a petri dish at the start of the experiment, how many bacteria are there in 1 hour, 2 hours, and so on? So it's non-linear because it's not a constant rate of change. This is doubling, which is the same as saying like times 2 and then take that number and times 2 again and then take that number and times 2 again. Repeated multiplication is the same as using an exponent. So we've got 100 doubled to 200 doubled to 400 doubled to 800 and so on. And so it starts curving up faster and faster and faster. So nonlinear things can also tell us about the general patterns happening. So we've got some linear, some nonlinear. We've also got some things that are changing in a variety of ways in one graph.